Hello guys, did you know that building a smart contract in Solidity differs significantly from doing the same on Solana? In Solidity, you work with a centralized smart contract holding both data and logic. Meanwhile, Solana takes a different approach, separating the data into accounts and the logic into program. Welcome to School of Dapps. In today's video, we will be exploring this difference by building a to-do list smart contract on the Solana blockchain. By the end of this video, you will not only build a functional to-do list smart contract, but also understand how the Solana blockchain development works. All right, let's dive into the
All right,
tutorial.
we'll be initializing a new project for the to-do list smart contract. So I'm creating a folder. I'll call it anchor to-do list. After creating the folder, I'm opening it in VS Code. Now we're in VS Code. I want to initialize the project by writing anchor in it, then the name of the um, project. So I'll write to-do list as the name of the project, to-do list. Then press enter. So I'm writing it in my terminal. Now the project has been initialized and these are the folders that has been created, and we'll be working on this smart contract which is located within the source folder under the program folder. So this is the boilerplate code that was given to us when we initialized the project. So from here we'll start writing what we the to-do list smart contract. All right, let's start building. Now in building a Solana smart contract, there is one thing I want you to take note of, which is that Solana is all about accounts. And this account can be broken into three major parts. We have one will be the program account, the second one will be the data account, and the third one will be the contest account. So the program account holds the logic for the program, holds the logic, the functions for the program, while the data account holds the data, everything about the data that we'll be working with, and while the contest account holds the contest, holds groups all the uh, all the account that we need to interact with the functions, with the logic in the program account. So understanding how this different account works will help you uh, be more proficient in building a Solana smart contract. So let's start with building the data account. Let's start with writing and constructing the data account. I will create a different module for that, a new module for that. I'll create a folder and I'll call it contest. I'll call it contest. I'll create a folder and call it contest. Now within this contest folder, I'll create two file. I'll call I'll create a file, two file. Yes, I'll create the first one. I'll call it contest.rs. Then I'll create another one and call it mod.rs. So in this contest.rs file, we'll be importing and we're having both the data account and the contest account in this file. So I'll show you. First of all, we'll start with writing the data account. So let's import anchor program. We're importing all the folder from all the file from Anchor Prelude models. Then we'll be creating an account where we'll store the datas. So we'll start with the macro declaration. What does account mean? It means that we are telling Anchor that the struct that I want to write now serves as an account that holds data on chain. So that's what this macro that we just declared means. We are writing the struct and we're naming the struct to do states. This is like the list that will be holding all the to do items. This struct will serve like the list that will be holding all the to do items. So, and we are putting in users the user's address, the person that will be. This is for you're stating the user's address and you're writing the bomb of a type U8 of a type U8. Then we are also writing a macro that will tell that will allow the maximum length. This macro is like a tag that tells the maximum length of the of what the list will be able to hold. Now just this is the to do list that will be holding all the to do tasks. So we say it's of the type to do. So we have just created this truck, which is an account on chain, and this truck will be serving like as the to do list, the list of to do that will be holding each specific task. Just like the way we have a sheet of paper and we are writing in the tasks that we want to accomplish, the tasks to accomplish. So this truck is serving like that list that will be holding every task that will be placed on it. So the next one we have to write. Now this macro that we declared here automatically adds several useful traits to the struct. Now this anchor deserialize convert the bytes into these structs. Then the anchor serialize convert this struct into bytes. Then this clone means that the the struct can be copied. This struct can be copied. They can be it enables an exact copy of this struct. Then the debug means it's like tag saying that it has the debugging functionality, allowing you to print out the struct. Then this init means that automatically calculate and allocate space needed for this struct on chain. So when we write this tag init space, we are saying that it will automatically calculate the and allocate the space needed for this struct to be on chain. Instead of us doing the manual calculation, we are telling the program to automatically calculate it and allocate the space for that will be needed for the struct on chain. So this struct will serve as a specific or individual task that will be placed in the list, the to-do list. All right, let's write out the items that will be individual in this task. Now, what we wrote here now, this in this part of this in this macro, we are saying that the length of the information that can be written in this description part is the maximum length should be 50. So anything the person is writing or anyone that's writing their tax, the length should not exceed 50. The maximum character should not exceed 50 characters. Then we also have a like you have a column that will be tick to say if the task is completed or not. So that's what this complete means. It means that it's going to give, if it is completed, if the task is completed, the person can mark it off that it is completed. So that's what it's doing here. And that's what why we're having it here to indicate if the task is completed or not. So this is a struct that serves as the item. This struct is not an account because an account macro was not written on it, unlike this to do state struct that the account macro was written on it. But this one will be is passed into the account, into this to do state. That's what we are having here to do. It's been passed. So the an item is being passed into the list, and the list is a vector. A vector is like an array that stores all the tax that is being passed into it. So the next thing we'll be doing will be creating a contest account. We just created the um, data account. The next thing we are doing, we'll be creating the contest account. Remember, the contest account is what will be having all the necessary information to interact with the program logic. So we'll be creating the contest account, and we'll start with, we'll call it firstly, we have to initialize the account to set up the account. To initialize the account means we have to set up the account. Now we are setting up the contest account, and we are saying this macro is stating that this signer is an account. This signer account represents the user who is sending this transaction. So the signer account is representing the user who is sending this transaction, and we are using mutable because it can change. The value of the user's account can change because when the person interacts with the smart contract, the balance of the value of his account balance can change. So that's why we are stating that it's mutable. And we are creating another account. Now in this part, we define the to-do account, which is being initialized. This word in it means that the account will be created in this instruction. That means when we are interacting with the initialized instructions, that is when this account will be created on the blockchain. The word seed is a unique identifier for this account. So it's the combination of seed with the combination of seed and the signer key. This is a constant to do account with the combination of seed and the signer key will be creating an address for the account. Then this is the payer, the payout that will, the person that will pay for the account to be created is what this payer means. Then the bulk has to do with it will be used in generating the the account address. So with the seed and the bulk, we are generating the account address. That means we can determine such an address. The address is not a random address, it's the address we can determine. So we are creating an address that we can determine. We can tell this the we can tell that using the same seed and the same bulk, we will always be able to arrive at the same address. Then this space is the size of the account in bytes. So this space is the size of the account in bytes. So we are saying creating the size of the account that we want the account to the size we want the account to have. That's what we are using this space to indicate. So this is the name of the account, to do account, and it's of type account. Then the lifetime is all through the lifetime of the function that to be used. Then this is the data account. Remember the data account. that was passed to it. So the data account is passed into this context account, and it will be used in the instruction while running the instruction to interact with the instruction. The instruction will be making use of this account, and in this very part, the instruction will be creating a new account that will be storing the data. We'll be creating another contest account. Remember, we said the contest provides the functions with the account it needs to interact with to execute the instruction. So we'll be creating the first contest that we created was is used to set up the account, the necessary account within the on chain. So this second contest we are creating is to add to do to the list. So you're still using the tags or the macro account, meaning the account of the user interacting with with this instruction, because this will be passed to this context will be passed to an instruction. So this is the user account. This will represent the user account that is interacting with that particular instruction that this context is passed to. Now this account is the to-do account that we initialized, that we set up in the previous instruction. Now in this context, we are retrieving the to-do account. Remember, we created it in the first context. In this second one, we are going to be fetching the account. Then we are going to modify it because we're going to be adding to do tags into the list, and that's why we have the word mutable here. So it will be adding to do tags to it. So we said the account is mutable. The account can be changed. So that's what it means. So this is an account that we have already created, but we are just fetching the account in this context. So this is the to-do context that we provide the to-do instruction with. So when we want to add to-do is to-do to the list, this is the context that we'll be working with. Next, we'll be creating the update to-do contest. So the contest will provide the to-do update to-do function with the account that is needed to interact with to execute the update to-do instruction. So we're going to be declaring the macro. So in this particular contest, we'll be updating the to-do. So we need the user account. This represents the user's account that will be interacting with the instruction function. Then this also retrieve in the account which has been initialized on chain, and we are able to edit, or we are going to be able to update the to-do tag or the tags that we have within the list. So this is the context that will be passed to the update to-do function. So when we want to update our to-do list, we'll interact with the to-do list update to-do function, and this is the context that the function will be working with. So we have written all the necessary context for the to-do smart contract. So now we'll move on to writing the main function. And before we write the main function, let's import our function properly. Let's import our model properly. So we are importing the file which we have written previously into this file, which is called mod.rm. So we import it in our library, in our lib file. Now in our lib file, we already have a boilerplate code. So we'll be working with the boilerplate code, which is from when we initialize our project with these codes we have found within the lib file. So we'll make use of some of the codes and we'll remove the one that are not needed. So we'll be importing Anchor prelude module from all the file from Anchor prelude module into the lib file, and we are declaring the program ID. Then we are declaring this macro program, indicating that this file is where the program will be running. Then you use the word use super. Then we are meaning we are importing every data or file from that's up at the top of the module. Then we have to also import the context file or context model which we written our data account and our context account in. So we'll be importing them. We use mod and context to import the file. Then we'll be writing the instruction for the smart contract. This function, this is the function for the smart contract. So when the user call this function, it will execute the instruction that has been passed into it. So in this first function, we are going to be initializing setting up the new account. When the user when the person that deploys the contract calls this function, or when a new user calls this function, it will create an account for that user. So we're going to name it initialize PDA. Then we are passing in the context. I guess that's what we used in our yes. So this is the context name that we used in our context file. So we are passing in the context that the function will be working with. And I'm not, we are creating a variable let and we call it account equal to one. You are fetching the to do account which is within the context account. So we are setting up the bob is for deriving an address on the blockchain. So what happened, we retrieve the account that is within the context account, the to do account. And if you remember, the to do account has um the to do account. Let me show you the to do account. It has data inside. This is the to do account. It has that was passed into the contest. It has bug. You can see the bug that we are initializing. It has the to do and other information within it. So we have initialized the bug and the bomb. And the next thing is we're also retrieving we're also retrieving the account to do total the account total. We're also retrieving the account total to do, and we are setting it to 0. This is the account. We are also retrieving the account total to do, and we are setting it to 0. And we are setting up the to do account, and we set up the bump value in the to do account, And we also set up the to do total to do in the to do account, which is we are setting it to zero, meaning no item as or no tax has been added. So it's set up to zero. And after that, we'll move on to the next instruction, which is to add to do to the account. Now let's quickly adjust this name of the instruction. Instead of initialize part, we are saying initialize PDA. Right. After writing the function, we can move on to the next instruction, which will be add to do instruction. So declaring the public and the function name. Function name is hard to do. We'll be passing in some parameters, some arguments. Then, okay, let's first of all pass in the context that we'll be working with. We'll also be passing in the description that will be written of a type string. Then we'll be fetching the to do list that has been initialized, to do account that has been initialized. We'll be fetching that account. We're getting it from the context that is being passed. Context does account dot to do account. We are fetching the to do account from the context and we are storing it in this variable called to do list. And within the to do account, which we've just fetched and stored in to do list, we'll be accessing the to do total to do count. So we'll say total to do list dot total to do. Then we'll be increasing it by one. What we are doing is that we are increasing the number of the item that is in the to do, since we are adding a tax into the to do in this function. So anytime we call this function, it will increase the number of the to do count. This total to do is like a count. So we are increasing that the count, saying that, oh, one additional item or tax has been added. Then we input all the data. So we were saying to do equals to. So we just imputed all the text. We imputed the text. So we are pushing in this tax which we have initialized. This tax which we have initialized, we are pushing it, which is stored within this to do variable. We are pushing it into the array now, into the list. We use the method push. Then that will be all that will be handling in this to do instruction, add to do instruction. Then we are moving this context from this because we already initialized our context in a different file. So what's going on? Why are we having this red line? What did we use in our context? Let's check. Okay, there's a mistake. Uh, the reason why it's showing this red line because this we didn't use is completed. We used a variable called completed. So that's why it's in throwing an error. So we have rectified that error and we can move on. So after writing the to do instruction, we can write the last instruction, which is the update to do instruction. So we pass it in the context. Make a mistake. I used font instead of FN, not FUN. Okay, there was a mistake which I've corrected, and you can check it again to note the correction if you're typing along. Want to retrieve the to-do list again, and in this very part, we ought to add mutable so we can. So in our to-do instruction, I forgot to add reference and mutable to the context, which enables us to um, modify the to-do list. So the same thing we do for the updates to do. When we are accessing or fetching the to-do list, we are to add, make reference to it and make a immutable reference to it so that we can modify the to-do list. So we are assessing the index of the because we will need the index to know to be able to get the particular spot where the tax is for us to modify. So the next thing we'll be doing is that we'll say to-do list. Now we'll access the to-do list dot the to do the array. Now we are accessing the array, the index of the array. We are accessing the index of the array dot completed. And we are setting it to is completed that is being passed in the parameters, either true or false. Then writing OK saying that it's successful. So this is all about the instructions that we've written. And let me quickly just recap the add to do function and update to do function that we wrote. Now in the add to do function, we declare the name and we pass in the context that the function will be working with. Remember, the context provide the function with all the necessary accounts to read from and write to or modify. Then we also pass in the string that will be added, the tags that will be added to the to-do list. Then we retrieve the to-do account, which has been initialized from the context. Then we increase the number of to-do item within the count of the number of to-do item within the to-do list, and then we set up the task, the description, and set that the complete is first, it has not been completed. Then we push it into the list. Now we successfully built our program, our contracts. The build is completed, so we can now test our contract. All right, after building our smart contracts, now we'll be writing our test file. And let's just head over to our test folder and write our test file. So we get to the test folder, we'll see to-do list test. Then want to start writing our test. And please permit me to quickly write the test without giving detailed explanation. So this is the test for the smart contract, and we imported the Anchor framework and the Coral XYZ Anchor framework. We imported the IDL from the target folder. Then we imported the public key from Solana Web3.js, and we imported aspects for ascertaining from this for ascertaining if the return will be exactly what we wanted. So it's for checking and all of that. Then we described the contract, the test file to do list, and we imported the anchor provider, network provider, and this is the program. Then created accounts. This is a derived account for the PDA that we use seed and the public key to derive. That's for that. And this is the first. This one is for testing the initialize function. If it's working perfectly, this is to testing. Is we I wrote this one to test the first function. No, we have two instruction in the smart contract. So this is testing the first instruction. Then why this is testing the second instruction. Part is testing the second instruction, and lastly, this one is testing the update to do function. So these are the tests for the theory function, and we are going to call get to open our terminal, and let me clear this from our terminal. It's cleared, and let's write our test. In order to test our program, we are going to write anchor test. Then I'm testing it with the devnet. On the devnet, I'm testing the program on the devnet, so I have to make changes anchor to my anchor folder, anchor tumor folder, this folder. Make changes to it. I changed this. It was local net, so I changed it to devnet, and I also changed this cluster to devnet, which will be by default to be local net in your own. So because initialize it, we initialize a new project. So the initialized project comes with local net. So but I changed it to devnet, and I changed the cluster to devnet. Then before calling the anchor test, you can see that the test went through, and this is the result for what we tested and adding to the to-do list and updating the to-do list. So this is for adding to the to-do list, and it passed, and also updating the to-do list. Now initializing the to-do account wasn't is not here because I have run the test before, and I've already initialized the in the first test I run. I initialized the to-do account, and so cannot be initialized two times. If not, it will throw an error. So that one has already been. I have to comment it out. So I run the test again for the to adding to-do list and updating to-do list, and this is the result. So like I said, don't forget to check the GitHub repository. So thanks for watching, and see you in the next video.